All right, so you've probably heard of the term agentic AI everywhere lately. It's kind of become a bit of a buzzword, but here's the thing. If you are serious about building with AI, you actually do need to understand what it means. And I suspect a lot of people throwing around the term don't truly understand what it means under the hood. So let's start there. What exactly is an agent? Think of it like this. Instead of one AI trying to do everything, you have multiple specialized AIs, each one with a clear job working together as a team, because agents can do things that single models simply can't. They can think through problems step by step, they can use tools, they can even make decisions about what to do next. So today, I'm going to show you exactly what agents are, how they work, and how to build your own multi-agent system from scratch. Because honestly, the best way to understand this is to actually build one. Specifically, we are going to build an AI that handles Twitter replies. But what you're really learning here, though, is the fundamental pattern that every AI product is built on right now. By the end of this video, you'll understand how to architect systems where AI can actually think and make decisions, not just respond to prompts. Let's get started. All right, so here is our game plan today. We are going to build an AI-based tweet reply bot that automatically responds to tweets based on sentiment and context. But more importantly, you are going to learn how to architect real multi-agent systems. Here's how we're going to do this. So step one, we'll set up a full stack project in Cursor with Python, FastAPI on the back end and React.js on the front end. Step two, we'll install LangGraph and build our very first agent just to see how it works, get familiar with the framework. And listen, if you don't know what LangGraph is, no worries. We're going to cover that in a moment. Step three, we'll step away from the code for a minute just to design what we want our agentic system to look like. And we'll do it using a Notion doc. I'll show you the flow, break down the anatomy of what a good agent is, and then we'll craft the perfect prompt to build everything. And then step four, we'll let Cursor build all three specialized agents for us using that prompt, the router, the specialist, the whole system. And then finally, step five, we'll test it with real tweet examples and watch the agents route and respond in real time. By the end of this video, you will have a fully working multi-agent system, and hopefully you'll have a better understanding of the agentic patterns that many of the systems that we use rely on. All right, let's dive in. All right, if you don't know me, my name is Sunny. I'm a serial founder now on my fourth startup, LightSwitch, where I'm CTO. I'm also a former senior engineer at Bloomberg and Shopify, and currently an adjunct professor at Columbia Business School, where I teach technology. Listen, I've been building software for over 15 years, well before AI, and I have made all the mistakes so you don't have to. My goal for today's video, and really all my videos, is to help you get your ideas out into the world. Let's get started. Okay, so before we dive into the code, we need to talk about why the agentic approach is different. So most AI tools today are basically just one model with a massive prompt. You tell it things like, be polite, fix grammar, answer support questions, sound professional, make jokes when appropriate, handle trolls gracefully. And it'll try to do all those things, but it gets confused, right? Because you're asking it to be everything at once. It's kind of like hiring one person to be your customer support team, your marketing team, and your security all at the same time. They're going to burn out, right? So that's where agents come in. So an agent is simply a model with a specific job. It has a goal, it has context, and sometimes it has tools it can use to accomplish that goal. So instead of one big model doing everything, we break things up. So for example, one agent for routing and decision making, one agent specialized in handling positive feedback, one for support requests, one for dealing with negativity. And together they form a system that can actually decide what to do next based on the situation. And this pattern is how real AI products are being built right now. All right, let's get to our first step. All right, so the first thing I'm going to do is I'm going to set up a blank cursor project. What I've actually done is I've created a empty folder called tweet reply bot and opened up cursor. It's completely blank. It's a fresh blank slate. And what I'm going to do is I'm going to paste in a prompt to basically set up the boilerplate. So we can have a basic Python FastAPI project on the back end and a React project on the front end. This is specifically what I'm going to prompt. Create a full stack project with Python FastAPI backend in a backend folder, React frontend in a frontend folder, basic folder structure and dependencies using pip file, a start.sh script that launches both servers with one command, and of course include an env file. I'll get into this in a moment, but let me go ahead and hit send on this. Now let me explain these technologies. All right, so these are the technologies that we're using. So FastAPI in particular, it's basically a modern web framework. It's fast, it's super easy to use, and has automatic API documentation. If you don't know what that is, no worries. But it just allows us to build a backend very, very quickly, and it's very well documented, so AI tends to handle it pretty well. Now, React is going to be our front end. This is the most popular way to build front ends. It's a JavaScript framework. This will be responsible for building our user interface. We're going to keep it super simple, just a basic interface to send tweets and see responses, nothing fancy. Okay, so it looks like we have everything set up here. Let's just take a little tour of what has been generated. So we have our backend folder. Very, very simple file. This is just boilerplate code. We have our front end folder. Again, very simple. We just have one basic page here. We also have an environment.example file. So this is where we're actually going to store our API key because we are going to be using OpenAI for this. More on that in a moment. I also want to draw your attention to this start.sh file. If you remember, we included that in the prompt. So this is going to be super handy for us because what this does is it basically is a shortcut for us to start the entire application. Remember, this application has two components, our front end and our back end. So instead of running a bunch of commands, we're basically just going to kick this off by typing /start.sh. And you can think of it like a start button for your entire app. One click and everything runs. So this all looks good. Let's actually go ahead and keep all these changes. I'm going to go ahead and open up the terminal. And if you don't know what the terminal is, it's just a very direct line of communication with your computer. And what we're going to be doing is we're going to be kicking off this whole project. We're going to be running the project. So that way we can access the front end and the back end through our browser. In order to start the project, I'm just going to simply type /start.sh, and that basically kicks off our back end and our front end. Specifically, the most important thing we need to know is what port our front end is running on. And again, this means that it's a port on your actual computer. So if I click in this, I should see this screen right here. This is basically the welcome screen. Again, this is just boilerplate code. This is just getting everything primed to start building the real business logic. All right, now that we have the basic project set up, let's move on to the next step. All right, so now we need to install LangGraph and build our very first agent. Just something super simple that we're going to build here because I just want you to understand LangGraph and the framework itself. So I'm going to start with this prompt. And what this prompt is going to do, it's going to do a couple of things. I'll read it in a second, but it'll install LangGraph and all the dependencies along with it. It's going to build the simplest possible agent that just kind of echoes back what we say, and it'll connect that to our basic UI. It'll create a basic UI for it, and then it'll set it up so that way that we're reading that OpenAI API key that we need. So let's read this a little bit here. So I'm hitting send. All right, so install LangGraph, LangChain, all of the packages, read the OpenAI API key from the environment variable. And while that's running, I want to go back to this environment variable example. So this is an example file that we have here. What we're actually going to do is we're going to copy this, and then we're going to create a real.env file. Now, this is where all of your secret keys are going to live. So what you're going to do is you're going to grab that API key for OpenAI from OpenAI's developer platform, and then you're going to paste that here. So now your application will read that API key to make calls to OpenAI's API. We like to keep all those secret keys in one place, this .env file, so that way we can hide it from any other developers or any other people that we may not want to expose it to. All right, so it looks like it's done. Let's inspect what Cursor has done. So looks like we added a bunch of more things to our single page, but I want to draw your attention specifically to our backend, specifically to this agent.py file, because this is our first agent, that very simple agent that we mentioned. So all this is doing is it's basically getting a response, and it's just passing along the message that we submit to this agent, and then it's passing it to OpenAI and then bringing it back. So it's like the most simplest thing, and it's using LangGraph for it. But first, what is LangGraph? So LangGraph is a framework for building stateful, multi-step AI workflows. So think of it like a visual programming system for AI. So instead of just calling one AI with a prompt, you actually define things like the nodes, which are the different steps that the agents work with in your workflow. You're going to define your state, which is the flow of data from one step to the other. And then you define what we call edges, which is the connections between these steps. So right now we have the simplest possible setup. One node, one state, one edge. The agent just takes your message and echoes it back. But the cool part is this structure scales when we add our router and specialist agents later. We'll just be adding more nodes and more edges to the same LangGraph setup. The pattern still stays. And this is the reason why I personally like LangGraph over using some of the other frameworks, because it's vendor agnostic. Right now, we are using OpenAI, but we can introduce another agent that connects to Anthropic. Maybe later, maybe in a month from now, we're going to get a completely new model, and I could just swap things out there. It's very important that when we are architecting our systems in this incredibly dynamic time that we're in, that we don't over rely on one company for every single thing that we do. It makes good business sense, good technical sense, and just a general good idea to try to diversify the AI models and the AI frameworks that we depend on. Okay, I will get off my soapbox and let's actually see if this works. So I'm going to go back to that front end, that local host, I believe it was 5173. All right, so this is our UI. Fantastic, looks good to me. I'm just gonna say hello, and then we get it sent back to us. So again, very, very simple use case. It's just parroting back everything that we're saying. Let's do another one. Goodbye, and it's parroting back. So we have completed our step 2, which was installing LangGraph and setting up our very, very basic agent. All right, so before we start building the real system, we need to actually design it. And this is actually the most important step. The mistake that I see most people make with AI is they just start jumping to prompting and kind of hoping for the best. But the best builders, they design first and then they build. So let's map out our agentic system. So here is how this is going to work. So a user sends a tweet, and then it gets sent to our first agent, which is our router agent. And the job of this agent is to analyze the sentiment and the context of the tweet. Is it positive? Is it a support request, or is it negative? And then based on that, it routes that decision to one of three specialist agents. We have the complement agent, which is designed to handle positive feedback. We have the support agent, which handles questions or issues. And then we have the troll agent, which handles any negativity or criticism. So that way, each specialist generates an appropriate response. That's what we send back. So that's the flow. Now let's talk about what makes a good agent. So every agent in LangGraph needs a few key things. So first, a clear role. So what is the agent responsible for? In our case, the router classifies and the specialists respond. 2, a backstory or context. So think of this like giving the agent a personality. So for example, the complement agent should be warm and enthusiastic. The support agent should be helpful and concise. And the troll agent should be professional, but not defensive. So that's basically the backstory or context. Third, specific instructions. So what should the output look like? How should it behave? The more specific, the better in this case. Fourth, state or memory. So what information does this agent need to do its job? The tweet text, maybe, previous content, that's it. So here's a pro tip. Keep your agents focused. The more you try to make one agent do, the worse it tends to perform. That's the whole point of this pattern. Instead of one agent trying to be everything, we have specialists. So like the complement agent doesn't need to know how to handle support requests. The troll agent doesn't need to know how to be enthusiastic. They each have one job and they do it really well. So now I'm actually going to write the specifications for each of our agents. This is going to be a document that I'll be using to actually put together the bigger prompt for Cursor. So here we have our 4 agents. Here we have the router agent. The role for the router agent is just to analyze incoming tweets and classify sentiment. The input will be the raw tweet text, output classification, which agent to route to. Here is the instructions: analyze tone, context, intent, look for positive language. And then we have the complement agent, which the role is to respond to positive feedback, gives it some backstory on being enthusiastic and genuine, keep responses warm. Then we have the support agent, which handles questions or issues, helpful, enthusiastic, being concise and actionable. And then finally, we have our troll agent, which is handle negative feedback and criticism, want it to be more professional and composed, and acknowledge their concerns without being defensive. So this is kind of like an agent spec doc. I would expect that even a non-technical person can prepare this. And of course, you could still use AI to support you in this, but really you should be in the driver's seat and making sure that this all makes sense for your agentic system. Perfect. So now I have clear specification for each agent. And again, this is actually how you should approach any multi-agent system. I want you to design it first, map out the flow, and then define each agent's role clearly. Because once you have this, building it becomes a lot more straightforward. You're not kind of figuring things out as you go. You're just kind of implementing the design. Okay, cool. So now that we have this, let's build our full prompt and then put that into Cursor. This is going to be the prompt that I put into Cursor. Very simple. Build a multi-agent tweet reply system. I give it some specifications on the architecture, and then I outline all of the requirements for the actual agents themselves. And then finally, some more requirements here. Cool. So we can actually paste this into Cursor. So it looks like Cursor generated a lot of code here, and I want to go to this agent system.py file. This is basically the entire agentic system here. So what we see here is all the different agents. So we see our router agent, and you'll see the system prompt, which essentially defines its role, backstory, instructions, and you see it, it's all here. You are a tweet classification expert, analyze a given tweet. These are the different categories that it's going to suggest. And what this is basically giving instructions to, it's giving instructions to OpenAI through the API. So now when we send the tweet to OpenAI, it'll basically follow these instructions to decide what other agent to send it to. Below, we also have our complement agent, so our first specialist agent. And it's all here. You are a friendly brand representative responding to positive feedback on Twitter. Be warm and genuine. Keep responses to 1 to 2 sentences. Use emojis appropriately, not excessively. So this is the purpose of this agent. Let's move on to the next agent. Now we have our support agent. You're a helpful customer support representative. Be helpful and concise. Acknowledge their issues. And then finally, we have our last specialist agent, which is the troll agent. You are a professional brand representative handling criticism. Stay professional, acknowledge their concerns, don't be defensive. So what Cursor has done is architected all of our agents here. But most importantly, I want to draw us attention to this, where we're setting up our entire workflow. So we see here that LangGraph is setting up a new workflow. It's adding all these nodes. Now, if you remember from earlier in the video, a node is a single step in our workflow. And then it's structuring the order of operations. This line of code here is basically saying our entry point for this entire workflow is the router. That's the first step. First, send the tweet to the router. And then from there, the router goes from the router to one of these agents, but on a conditional basis. So that's what I mean. That's what it means by conditional edge. Basically, a conditional entry point or a conditional connection point, like a fork in the road, right? But it can either go to the complement agent, support agent, or troll agent, depending on what the router decides. And then from there, if it goes to the complement agent, then it's done and it ends the workflow. If it goes to the support agent, then it's done and it ends the workflow. And if it goes to the trolling agent, then it's done and it ends the workflow. Now, this is where LangGraph really shines, because this graph is basically your recipe, your order of operations. Think of it like this. You have all these agents, but they need to know what order to run and kind of how to talk to each other here. This graph is literally your logic to your entire system. And it's important to know where it is in your code and just be able to read through it, because you want it to be consistent with what you expect it. You should have some stake in how this agentic system is architected and the flow of information. Back to our UI, we're going to test this system. As you can see, Cursor has updated the UI to reflect our main use case. So I'm going to first start with a compliment tweet. So your product is absolutely amazing. Let's generate a reply. And look at that. It indicates very clearly that it's a compliment agent that's handling this. Thank you so much. We're thrilled to hear from you. So that's coming directly from the complement agent. I also want to do a support request. So, hey, I'm having trouble signing up, getting an error when I try to create an account. So this should route to our support agent. And look at that. It's now being routed to our support agent. I'm sorry to hear you're having trouble. Could you please DM us? So it's just trying to be helpful but warm. And finally, we will do the fun one, which is the troll agent. This app is complete garbage, waste of money. So let's generate a reply. Cool. So we have the troll agent. We appreciate your feedback and take your concerns seriously. We're here to help improve your experience. So we've tested everything. Everything looks good. We've successfully built our first agentic system. Let me zoom out for a second, because this pattern we just built, this is everywhere in modern AI. We have entered the era of specialized AI systems. The companies winning right now aren't the ones with the biggest models. They're the ones building the best systems. Think about Perplexity, for example. So they don't actually have better models than Google, but they have built a better system for routing queries, for searching multiple sources and synthesizing results. Same with Cursor, same with any good AI product you use. It's not about raw model power anymore. It's about orchestration. And that's exactly what we did here. We orchestrated. We gave each agent a specific context, a specific job, and let them do what they are good at. The more specific that context was, the better the outputs. And the safer and more controllable the whole system becomes. Now, here is the key insight. AI models are really good at specific tasks. They're not good, though, at being everything to everyone in one single prompt. So the future is not about who has the biggest model. It's about who builds the best systems. The ones that route intelligently, manage contexts, and use the right specialists at the right time. That's who wins. Frameworks like LangGraph make that design visible. You can literally see how your AI thinks. You can debug it, improve it, and explain it to someone else. So once you kind of get this mental model, you can start thinking in terms of agents and graphs instead of just prompts. Every other app you build becomes almost 10 times easier, because you're not wrestling with one massive prompt anymore. You're actually architecting systems, and you can swap out the underlying models at any time. Today, OpenAI, maybe tomorrow, Anthropic. Next week, a totally different model. Your system logic stays the same, but the models themselves can be interchangeable. That is the power of building with frameworks instead of APIs, and that is the power of building agentic AI. So to recap what we built, we did the following. We created a multi-agent system that routes incoming tweets to specialized agents based on sentiment. We used LangGraph to orchestrate the entire flow, and we kept it vendor agnostic so we can swap out models anytime we want. Now, here is your homework. I want you to take this exact pattern and apply it to something you care about. Maybe it's customer support emails instead of tweets. Maybe it's routing questions in a Slack bot. Maybe it's triaging bug reports in GitHub. Doesn't matter what it is. The pattern is the same. It's a router plus specialists. Build it, ship it, drop it in the comments, or tag me on Twitter. I genuinely want to see what you come up with. And here is the bigger lesson. We are no longer in the prompting era anymore. We are in the systems era. The people who win are going to be the ones who stop treating AI as this black box and start treating it as a set of tools that they can orchestrate and control. So go build systems. Don't just prompt, architect. If you made it this far, I appreciate you. I will see you on the next video.